This was the problem that we did recently that I got mixed up on the end because I made a arithmetic error. So I thought we should do this problem again by video so that you can study it. Suppose that phi is a homomorphism from Z50 to Z15 with phi of 7 being 6. Well, right away let's jot down some things that we know. We know that phi preserves the algebra. So let's write phi is algebra preserving. Just write down what you know as you're given the problem so that you don't have to keep looking back at it. We know that phi of 7 is 6. So in other words, if phi of 7n, let's say n is 3, 7 plus 7 plus 7 would be equal to 6 plus 6 plus 6. So it would be equal to 6n. But of course the 7n over here is in Z50, so we calculate it mod 50, and 6n is in Z15, so we calculate that mod 15. So these are the first two things we know. Now it wants us to determine phi of x. Well, I would not ask you to get a formula for phi of x, but actually you could, this would be sufficient, just to say phi of 7n equals 6n. But again, I'm not going to ask you that because the formula is not in terms of x and we haven't done much of that in class. Determine the image of phi. Okay, well right away we know the image of phi is a subgroup of Z15. And we know that phi is onto the image. Let's write that down. Phi is onto. It's an onto mapping onto the image of phi. So determine the kernel of phi. Well, let's write what we know about that. The kernel of phi is a normal subgroup of Z50. And it is the set of elements that get mapped to 0 in Z15. And now we want to determine phi inverse of 3 as the fourth part, and phi inverse of 3 would be equal to the set of all x in Z50 such that phi maps x to 3. And we've learned in studying the isomorphism theorem and studying cosets, we know that this will turn out to be a coset. This will be a coset of the kernel. So we'll have to figure out which coset it is. So part B asks us to find the image of phi. So since we know that the image of phi is a subgroup of Z15, we know that there are only certain possibilities. The image of phi has to be Z15, or it could be the subgroup generated by 3, or the subgroup generated by 5, or just the trivial subgroup containing the identity. Now the corresponding orders, let me write corresponding orders for these. The order of Z15 is 15. The order of the subgroup generated by 3 is 5. The order of the subgroup generated by 5 is 3. And of course, order 1 for the trivial subgroup. Since phi is mapping a group of size 50, Z50, onto the image, we know that the order of the image will have to divide 50. And so we see there are only two possibilities. The image of phi is either the subgroup generated by 3, or it is the trivial subgroup. But the image of phi can't be the trivial subgroup because then phi of 7 would be equal to 0, not 6. Therefore, we can answer the image of phi is equal to the subgroup of Z15 that is generated by 3, which is 0, 3, 6, 9, 12. To find the kernel of phi, let's look at the possibilities. We know that the kernel of phi is a subgroup. In fact, it's a normal subgroup of Z50. So let's look at the possibilities for the kernel. The kernel of phi must be equal to, well, it could be Z50. That's a normal subgroup. All subgroups are normal because it's abelian. It could be the subgroup generated by 2, the subgroup generated by 5, or by 10, or by 25, or it could be just the trivial subgroup. Those are all the possibilities because those are all the normal subgroups of Z50. Let's write down the corresponding orders. Corresponding orders. Well, Z50 has order 50. The subgroup generated by 2 has order 25. The subgroup generated by 5 has order 10. The one generated by 10 has order 5. Order 2 for the subgroup generated by 25, and 1 for the trivial subgroup. Now remember, we know that Z50 mod the kernel of phi is going to be isomorphic to the image, which has 5 elements in it. So let's write down the order, the corresponding orders of Z50 mod these subgroups. Let's just put n for normal subgroup. The corresponding orders. Well, the order of Z50 mod Z50 is 1. The order of Z50 mod the subgroup generated by 2 is 50 divided by 25, 2. 50 divided by 10, 5. 50 divided by 5 is 10. The order of Z50 mod the subgroup generated by 25 would be 50 divided by 2 is 25, and the order here would be 50. Well, this image has 5 elements in it, so we know what the kernel is. The kernel of phi is equal to the subgroup generated by 5 in Z50. So it's 0, 5, 10, 15, on up to 45. So we are given that phi of 7 is 6, and in order to find phi inverse of 3, that coset, we have to know what at least one number in Z50 that is mapped to 3 by phi. So let's just start out. Phi of 7 is equal to 6. 7 is a generator for Z50. So we could figure out all 50 mappings, what every single element was sent to. But let's just go until we get to something that maps to 3. So 7 times 2 is 14. Will map to 6 times 2 is 12. Then 7 times 3, 21, will be mapped to 12 plus 6 is 18. In Z15 is, oh, there it is, 3. So we know that the coset containing 21, every element in that coset gets mapped to 3. So the coset containing 21 will be 21 plus the kernel of phi. And that is phi inverse of 3. You just need to find one element that maps to 3, and then the coset containing that element, which of course would be 21 plus the kernel of phi, 21 plus that coset. Remember, we use plus because the operation in our group is addition.